I'm here talking with Amit Singhal, who's a senior vice president and Google fellow, and he leads search at Google. He was also an alum of our PhD program here at Cornell. I guess you actually got your PhD same year I showed up as a new assistant professor, I think. So.
Yes, indeed. And sorry, there's no correlation there, John. I didn't want to leave the department as soon as you showed up or anything like that.
Yeah, well, so it's great you can join us and take part in the course like this. We've certainly been talking a lot about the web and web search and things like that. And, and this being a course about networks and about big groups of people and how they act and how they interact. A sort of great example for us has been the web as a big network and a big network linking information together. And and then so you're at Google, which is this end-to-end system that sort of does the whole thing. I mean, so how do you think of it? Like, network is obviously one ingredient of what you guys deal with. The web is a big network, but how do you guys think about the ingredients that come together in search? How do you put them all together?
Yeah. So before I start about how modern search is put together, let me just quickly run through some of the basics of how search really is built and how does it work. So to build a web search engine, the very first thing that you need is the web, and every search engine needs a copy of the web in-house so that the search engine can process it to be returned as results when you type a query. And so the very first thing every search engine does is web, which is simply follow the hyperlinks of the network. And every time you find a new page, a new node in that network, you just get it and save it to your servers so that you can process it for returning later. And after the crawling step, once we have crawled billions and billions of these pages and brought it in-house, the next step is building an index. And an index is very much like the index you see at the back of a book. You can type a word and you can figure out which pages have that word. And having built the index, then you have to figure out what are the most salient pages when a user types a 2-word query or a 3-word query or a 1-word query. And that process is known as ranking. You have to figure out what are the most relevant pages to that query. And that's where numerous signals that we have gathered from the web and user behavior signals, and you name it, go in. This is the area that I started out with at Google. I was part of the ranking team and built a new ranking system when I arrived here. And you have to do all this over and over again, find the best documents, give them context snippets, which is keyword in context snippets, and we have to do it like 3 billion times a day. And that's what goes into building a commercial web search engine. And this is where, let's dig deeper into parts of the system. Clearly, the web is a big network. We have lots of network signals, PageRank being one of the key signals that Google uses, which models, you can think about PageRank in numerous ways. But, I think about it as a network flow problem, that if you were flowing things in a network, where would they accumulate? If you were flowing goodness in a network, what pages would accumulate that goodness? And those pages tend to have high page rank. That is, many people link to those pages. There is lots of inflow into those pages. And you can come up with, we have used numerous scientific theories in building what Google is today, from a multitude of subject areas, information retrieval being my area, network flows, and all the other network algorithms being John's area, and numerous other systems areas, machine learning, you name it. That's what it takes to build a commercial engine like Google.
Yeah, I mean, it's exciting that, a big system like Google serves as a showcase of a whole bunch of, computer science ideas and ideas from a lot of other subjects, and they're sort of all brought together. I mean, I also like the fact, the way you guys think in terms of signals, right? That everything is sort of, lots of things are providing a signal, and then, the question is sort of how to synthesize all of that. And so you mentioned, that the network provides a lot of signals. Obviously, text provides signals, and I guess a whole bunch of other things. Elsewhere in the course, we've talked briefly about, that the time when you issue a query, the geography from which you issue a query, things you've done before, all of those kind of also, flow into how to evaluate what are the right results for somebody.
Indeed. Indeed. So, when building these systems, you have to think about signals and what would be the most, how do you come up with the most relevant results? What signals are important? Like, in the example that you are using, if the query is pizza, then clearly the most relevant results depend upon where you are. If the query is sushi, if I returned to you in Ithaca or me in California, results from Tokyo, you would not be very happy. And so that's one type of a signal that immediately comes into play when writing a ranking system, which is what geography the user is, what geography does a page relate to. So that's one example of a signal. You can start with rudimentary signals like, does this word belong to a title of a page or not? Does this word belong in a header, H1 of a page or H2 of a page or not? Does this word show up higher up on the page or lower down on the page? So these are all signals that give you kind of the scent of relevance, just a tidbit about whether this document is salient, relevant, or not. And then we have written a big scientific system, largely motivated by foundations of information retrieval, that combines all these signals given a user query and a document to come up with a numeric score, the relevance score, based on which we sort and return to you the top most relevant documents.
Yeah. No, it's really interesting. I mean, so when I think about the parts I kind of most naturally think about, the sort of the graph and the network of hyperlinks. I think what's interesting is when I so certainly when I think about that stuff, and a lot of people I talk to, we have these intuitions that were based on kind of our own experience as grad students using the web in 1994 and 95. The idea was you would browse and you would explore and you would search and you would find these serendipitous connections through the hyperlinks, and of course what the whole network looks like has changed a lot over the years. I almost think like when I'm on Wikipedia, I sometimes think of it as almost like this sort of Disney World version of what the web used to look like, with all these pages about sort of encyclopedia topics with these links between them. But out there in the sort of wilds of the new web, there's all sorts of other forms of linking. I'm like, how much do you feel like the graph has really changed, and is that sort of a challenge to the way you guys think about using the network signals?
This is a great way to look at the web. Very, very insightful way to look at the web. When the web started back in 92, 94, 96 time frame, we would largely web was pages put up by people who were passionate about something, and links were recommendations to things that they really cared about. Right? That's how we thought of pages and links, and that's how we built PageRank or various other systems that you were part of building at IBM. And since then, things have evolved tremendously. Back then, there was nothing called e-commerce. Back then, it was just a bunch of pages that people liked and put up there. And clearly, the web has changed tremendously. Not only has e-commerce arrived, it is one of the big components that you and I use on the web every day. And at the same time, web has also come up with apps. Now there are full sites using, built using various programming languages, which are pretty much like an app or a program running inside a browser. Back then, all this was not mature at all. So clearly, one of the key shifts that has happened is back in 94, when there was a link going from one page to another, it was a much purer form of recommendation than it is today, because it was done out of generally enthusiasm for the topic. And clearly, over the last 15 or more years, almost 20 years now, because of various commercial interests, the quality of link isn't as pure as it used to be. That's one of the big challenge that we have addressed very successfully, because you have to kind of make sure that your algorithms work with what's really out there. I don't have the luxury of living in a world where I can assume every link is a recommendation, and a good recommendation at it. So that's one example of it. Another big problem that search engine space is that with all these programs embedded in a browser, right, you can pretty much play Angry Birds inside a browser. Now, how do you index a screen in that world?
Yeah.
What does that really mean? And so these are the things that we at Google pay close attention to provide the service that Google provides today.